Kirtana. I'm the routing developer. So today's topic is performance evaluation of AODV and static routing protocols in wireless sensor networks. These are our teammates. Next slide. So in this project, we used OMNeT++ to simulate a small wireless sensor network. Our network has 25 sensor nodes arranged in a 5 to 5 grid with obstacles plus one sync node that collects all the data. The nodes generate random traffic with the packets sent every 0.7 to 1.4 seconds, and each node starts with limited energy and a 3-volt supply. Next slide. Our main objective is to build this 25 node network and to compare two routing strategies, that is AODV and static routing, under the same conditions. We measure the delay, packet delivery ratio, and energy consumption. And we also want to highlight how real environments with obstacles and limited transmission range affect these metrics. Next slides will be continued by my other teammate.
I am Gautam Darapogo and I dealt with the topology in this project. Here we can see the simulation setup. We created a 25 node wireless sensor network arranged in a 5 to 5 grid. We added obstacles so not all the nodes can see each other directly, and each node can send data up to 28 meters. So packets travel in multiple hops. The next slide, please. In the next slide, we evaluated two routing protocols on this topology. Protocol A is AODV, which finds routes only when we need it and can change them if the path becomes bad. And the second one is the static routing, where the routes are fixed in advance and nodes always follow through the same path. This let us compare a dynamic and static approach under the same network conditions. Next, my friend is going to continue.
My name is Saipriya Ramani, and I worked as an energy engineer for our project. And coming to this slide, here we summarize the three key metrics we measure during our stimulation. And first, end-to-end delay, which tell us how long a packet takes to travel from a source node to the sink. This helps us understand how responsive the network is. And the second is a packet delivery ratio, or PDR, which shows how many of the packets generated by the nodes actually reached the sink successfully. A higher PDR means the network is more reliable and stable. And finally, the metric most related to my role, the final residual energy. This measure how much battery each node has left at the end of the stimulation. And coming to the next slide, and these are our measured metrics for our project. And my next slides will be continued by my teammate.
I am Sumirat, the project lead. Here are our main results. We saw that AODV behaved better when some paths were blocked because it was able to quickly find new routes. When the links were stable, static routing actually gave lower delay since packets always used the same fixed path. Finally, we noticed that two protocols use different energy differently, mainly because their routing behavior and control messages create different levels of overhead. Next slide will be continued by my teammate.
So in conclusion, our results showed that there is no single best routing protocol for all the situations. And also in dynamic or unreliable networks, AODV works better because it can quickly change between the routes. In a stable topology as well, simple static routing can be more efficient. So the routing protocol must be chosen based on the specific deployment requirements. Now we'll go to the demo. So this is our environment where we performed our project, which is OMNeT. And here, as you can see, this is the workflow of our project. And this is the config file given to us as we are group 6. When we click on Run As and click on OMNeT Simulation, and this is the config name which we have to select, which is group 6, which is 5 into 5. And here we can see various run numbers. And for now, I'll click 0. As you can see, this is the 25 nodes, which has 5 into 5 matrix grid. When we click on run, it usually needs to go on for 1800 seconds. But since we don't have that much time, I'm just going to go to stimulate. and click on Express Run, where it would run expressly and it would go to 1800 seconds, and here you can see the pop-up message where the time has been reached. And then when we close the simulation and we can come to the workspace again, we can look into the scalar and vectors files which are generated over here. And since we have to generate 3 different plots, we can click on the filter and click on the plots which we need, where it is delay. On delay, and here we can see all the delay in the vector files and the scalar files, and the generated plots could be viewed over here, which is, so this, as you can see here, it is the PDR as well, and the delay plot. So these are the generated plots from the scalar and vector files, and we have also found the energy plot over here as well. Thank you.